Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is the procedure programming module, and the same chapter, that is chapter number 19, interaction with the hardware. In the last class we have discussed how to communicate with the storage devices. There are different storage devices that is available, and we have talked about how to communicate with these storage devices like LAN, cable, uh, keyboard, mouse, floppy disk. So how to communicate with these storage devices, that is the interaction among the storage devices. This says since DOS is commercially dead, the rest of the chapter would focus on communication with the devices under Windows. That is the rest of the chapter, or the rest of the topics that we have left in this, we have dealt with the how to communication or how to make the communication with the devices under Windows platform. Let us begin with the one that interact with the simplest storage device, namely the floppy disk. So this is the basic, or this is the first part, that is how to make the interaction among the storage devices, simplest storage devices, for example the floppy disk. So we have discussed about this one, that is how or what is the structure of the floppy disk, how we are using the floppy disk. That consists of four parts. What are the four parts? One is boot sector, one is the file allocation table, that is a FAT, one is the data space, one is a directory. So there are four parts. We can use these logical four parts that consist of a floppy disk, right? So that is how many sites it contains, how many tracks it contains. So there are various questions that arises, that is how to use this one or how to organize these content. The directory contains information about the files like its attribute, name, size, etc. The FAT also contains the information about where the files and directory are stored in the disk or data space. This is the example, this is the figure that shows how the what are the four parts, logical parts of a floppy disk. These are the four parts of a floppy disk. This is site 0, track 0, site 0, track 1. This is the example that we have discussed, that is how to communicate with the storage device, for example the floppy disk. This says with the logical structure of the floppy disk behind us, let us now write a program that reads the boot sector of a floppy disk and how it will display on the screen. This is the example that is given, that we have discussed about the example. So we have talked about this example, that is how to communicate with the floppy disk, what is the boot sector, and how we are doing the floppy disk arguments, floppy disk viruses. So this says, well, that's what all Windows-based antivirus software do when they scan for the boot sector viruses. There are various terms, there are various scenarios in which we are using the boot sector viruses. A good enough reason for us to add the capability to read a boot sector to our knowledge, that is it is also the possibility to read the boot sector for our knowledge, so that it can be understandable or it can be understood for the good reasons. This is the example, that is a hash include stdafs.h, window.h, stdi.h, conio.h. These are the header files. This is the pegma pack1. Then there is a struct. This is a structure, that is the structure name is boot, and there are various content in this structure. For example, byte, that is jump, that is this is a macro, that is a byte, and jump is the name of the variable, that is a jump 3. This is an array that contains the value from 0 to 2, that is 0, 1, 2. Then char bsom name, this is also a variable, this is also an array that contains 8 values, that is from 0 to 7. Then word, then bytes per sector, then byte, sectors per cluster. So these are the various variables that is defined based on the macro. Then there is a reserve, that is also a variable that contains 480 number or 480 variables, that is from 0 to 479. Then this is the function that is declared, that is void read sector char pointer src int ss int num void pointer buffer. This is the function, that is a function calling, that is how to use the function, that is a read sector. This is the void main, that is the main function. This is the variable of the structure that we have declared or that we have used, that is b. Then this is the important part, that is how to read the sector, or this is a read sector function. Then there is a printf. Then boot sector name, this is the printf that is used for printing purpose, that is printing the ID, printing the BPS, printing the SPC. Then this is the function, that is the function definition. This is the function calling and this is the function definition. How do I know this is the function calling? Because there is a semicolon against this. But there is no semicolon against this, so this is a function definition. Then there are multiple variable that is declared, that is handled h unsigned int br, then h equals to create file, that is used for creating a file. Then src, generic read, file share, read 0, open existing. So these are the various arguments that is used for the create file. Then this is a set file pointer, that is the next function that is used, that also contains multiple functions, multiple variables. Then this is the explanation that contains two parts, that is a boot parameter and the disk bootstrap program. The boot parameters are useful while performing read or write operations on the disk. So these parameters are very important in performing the read and write operations on the disk. For example, this is the figure that shows how to make the read and write operations. These are the various instructions that is given. This is the description, this is the length, this is the typical value. And in this paragraph we have studied what do you mean by the boot sector, what is pragma pack, what is the Windows main, that is how to use the window main, how to use the main function. Then this is the read sector function, that is very quite similar to the absolute library function that is available in the Turbo C or the C++ under the DOS. These are the various, or there are various parameters that is available for the read sector. In this paragraph it is given the first parameter of this one is this one, that is the first parameter. Then this is the device name, then this is used for the machine name. There are various parameters, and yeah, there is one that is parameter. This will specify that is how many bytes occupies a single sector. The last parameter is the address of a buffer variable that would contain or that would collect the data that is read from the floppy. Then it is saying that once the content of the boot sector have been read into the structure variable B, then we have displayed the first few of them on the screen using the printf. So this printf is used for the screening purpose. Then in the next line it is saying if you wish you can print the rest of the content as well. Then the next function is read sector function, that is the next function that is used in the day-to-day scenarios, that is the read sector function. This function begins by making a call to the create file function. This is the API function that is used, that is the usage of the read sector function. This is the create file function that is used. There are various arguments that is used in this. One is src, then generic read, then file share, read, then 0, open existing, 0, 0. These are the various arguments of the read sector function. We have discussed in detail what do we mean by the create file, then what is the create file API function, generic read, file share read flag. What do you mean by the set file pointer? We have discussed all these things in the or with the help of the this variable. Then we this is also the example that we have discussed, that is using the write sector example. And then these are the various variable that is declared in this. Then the next one is or the next topic is accessing the other storage devices. This is also we have discussed, that is how to access the other storage devices other than the floppy disk, other than the other for example magnetic tape, magnetic disk, CD-ROM, hard disk. So how to access that other storage devices. These are the few interesting points that you must note. So these are the few interesting points. These are the 5 points, interesting point. Then the next one is communication with the keyboard. That is how to communicate with the keyboard. So this is the today's session, that is the today's topic. So in the last class we have finished with the how to communicate with the storage devices. Now this is the next part, that is how to communicate with the keyboard. This is like mouse messages, there also exist messages for keyboard. That is like a mouse message, there also exist messages for the keyboard. There are WM key down, WM key up, WM care messages, these are available. Of these, key down and the key up are sent to an application whenever the key is pressed and released respectively. So whenever there is a requirement for the key down or the key up, so this is sent to the application whenever there is a key pressed or whenever there is a key released. The additional information in case of these messages is the code of the key being pressed or released. When we tackle WM key down or WM key up, we need to ourselves check the status of our toggle keys like numlog. So whenever we use these keys, either WM key down or WM key up, then we use the status of our toggle keys like numlog, shift key, control, shift. If we wish to avoid all this checking, we can tackle the WM care message instead. So this is the example, that is how to communicate with the keyboard using these functions, using these scenarios, using these keywords, that is the WM key down, key up, care, WM key up. This is what is mentioned above is the normal procedure followed by the most Windows application. So this line says this is the normal procedure, that is a window key down, window key up. However, if we wish to go a step further and deal with the keyboard, we need to tackle it differently. That is, if we wish to go further or wish to go a step further, that is a beyond further, and deal with the keyboard, then how to, or we need to tackle it in a different way. For example, suppose we are to perform one of the following jobs. That is, this is how it will be different in a, or how it will be used in a different way. The first one says once you hit any key, caps lock should become on. So whenever you hit any key, the caps lock should become on, or caps lock is on. Once it becomes on, it should remain permanently on. That is, it should remain permanently on. It cannot be deactivated or cannot be off. That is on. I mean, always. If we hit a key once, it should appear twice on the screen. So if I press any key, it should appear twice on the screen. Next point says if we hit a key A, then B should appear on the screen, and B, then C, and so on. That is, the next character will print on the screen. Note that all these effects should work on a system-wide basis for all Windows 32 applications. So there is a difference between the Windows 32 applications and Windows 16 application or Windows 64 application. So this is the case, or these are the various effects that is available on the system, or that is available for the Windows 32 application. To be able to achieve these effects, we need to understand two important mechanisms. What are the important mechanisms? That is dynamic linking and Windows hooks. Now let us understand these mechanisms one by one. That is how these effects will be appear. That is, whenever we press a key, it should appear on the, or twice appear on the screen. And when if we hit a key, that is A, then B should appear on, that is next character will appear on the screen. So there are two mechanisms that is used. One is dynamic linking and one is Windows hook. So there are two mechanisms. These are the two mechanisms that is used. The first one is the dynamic linking. This is the first part, that is the dynamic linking. So this says, as we saw in chapter 16, that is whenever we do the C under the Linux or C under the Windows. That is, Windows permits linking of libraries stored in a .dll file during execution. So we see that Windows also permits the linking of libraries. That is, how to link the libraries, or how to permit the linking of libraries that is stored in a .dll file. That is a dynamic link library file during execution. Then next point says a DLL file is a binary file that cannot be executed or that cannot execute on its own. So a DLL file, that is a dynamic link library file, is a binary file that cannot execute on its own. It contains a function that can be shared between several applications running in a memory. It is not the case, or it is a binary file that cannot execute on its own. Rather, it contains the various functions. That is, various functions are available in the DLL that can be shared between several applications or between different applications that is running in the memory. Then the next one is your Windows hooks. That is the next concept. So one is the dynamic linking that is done by the DLL file, that is a dynamic linking library. Then the next part is the Windows hooks. As the name advises, the hook mechanism permits us to intercept and alter the flow of messages in the operating system. That is, this is the method that is used, that how we can flow the, or how we are altering the flow of messages, how we are able to change the flow of messages in the operating system, that is the OS, before they reach the application, before they move to the application. Since hooks are used to alter the messaging mechanism on a system-wide basis, the code for hooking has to be written in a DLL. That is, since hooks are used to alter the messaging mechanism on a system-wide basis, the code for hooking has to be written in a DLL file. The hooking mechanism involves writing a hook procedure in a DLL file and registering this procedure with the operating system. That is, this is a mechanism that involves that first of all write the code for the hook in a DLL file, then register this procedure with the operating system. Since the DLL cannot execute on its own, we need a separate program that will load and executes the DLL. This is, since the DLL cannot execute on its own. Why? Because it is a dynamic linking library. It cannot execute on its own. Rather, it needs a separate program that would load and executes the DLL. For different messages, there are different types of hooks. For example, there is a message for the altering the message or for altering the content. So there is a separate hook for the separate messages. For example, for keyboard messages, there is a keyboard hook. For mouse, there is a mouse hook. Means every device messages like keyboard messages, there is a keyboard hook. For mouse messages, there is a mouse hook, etc. You can refer MSDN for nearly a dozen more type of hooks. That is, you can refer the MSDN, that is a device, for nearly a dozen more type of hooks that is available. Here we would restrict our discussion only to the keyboard hook, because we are dealing with how to communicate with the keyboard. So this is the we are using the only the keyboard hook. This is the normal working of a message. That is how the normal working is done. This is the keyboard. There is a keyboard interrupt. That is a interrupt is coming from the keyboard. This is the kernel routine. There is a device driver ISR. So this is the interrupt, kernel routine, device driver ISR. The key is pressed from the ISR that obtain the key code by interacting with the KB controller. So that obtains the key code by interacting with the KB controller. So there is a keyboard, then there is a kernel routine, then there is a device driver ISR. Then after the device driver ISR, that place the key code in a system message queue by calling the keyboard event. That is used for calling the keyboard event. That is used for making the or enlarging the keyboard event. Then there is a system message queue. That is the blocks are maintained in a form of a queue. Messages are maintained in the form of a queue. So there is a keyboard, there is an interrupt, there is a kernel routine, there is a device driver ISR, then places the key code in a system messaging queue by calling the keyboard event. Then there is a system message queue, then there is the operating system, that is the OS, that is deals with how to interact with the or how to maintain the queue of the messages. So these are the various concepts. That is simply whenever we use the mouse. Suppose I taught you in the last class, right? Yeah, or I'm right now I'm teaching you, right? So there is a keyboard usage. I click with the mouse, I click with the keyboard, there is a entry, That is, if I want to write, then I can write it by using the keyboard buttons. So there is a concept, there is a keyboard. This is a normal working, that is how to use the keyboard. So whenever there is a hit key or there is a key pressed with the keyboard, there is an interrupt, then kernel routine, then device driver ISR, then there is a system message queue, and then OS decides from which place or from which application into which application it is placed. The message is gone into the which application, either in the notepad, either in the Visual C++ or VC++. Right. So this is the example. This is application 1. This is the application 1 message queue. This is application 2 message queue. This is application 2. There are different scenarios, different mechanism that is used in this one. Now, this with reference to figure 19.7, that is this figure, there are list of steps that is carried out when we press a key from the keyboard. So whenever we press a key with the keyboard, there are various steps that is available that is carried out whenever we press a key from the keyboard. What are the various steps? That is, on pressing a key, an interrupt occurs and the corresponding kernel routine gets called. So whenever we press a key, an interrupt occurs and the corresponding kernel routine gets called. Corresponding kernel routine means whenever we press any key, there is an interrupt, right? And the corresponding kernel routine, that is how to deal with the messages, how to obtain with the messages, gets called. Then second point says the kernel routine calls the ISR of the keyboard device driver. So it is the responsibility of the kernel routine that calls the ISR, that is the interrupt service routine of the keyboard device driver. Then so first of all, pressing a key, interrupt occurs and the corresponding routine gets called. Then in the second point, the kernel routine calls the ISR of the keyboard device driver, that is deal with the, or that calls the ISR. Then ISR communicate with the keyboard controller and obtains the code of the key pressed. Then ISR calls the operating system, that is a keyboard event, to post the key code to the system message queue. These are the main 4 points. First of all, press a key, interrupt occur, then corresponding kernel routine gets called. Then kernel routine calls the ISR. Then ISR communicate with the keyboard controller. Then ISR also calls a OS function, that is a keyboard event, to post the key code to the system message queue. Then last point says the operating system retrieve the messages from the system message queue, because there is a system message queue that is maintained, that is done by, or that is used by using the keyboard event. So it posts the messages, or it retrieves the messages from the system message queue and posts it to the message queue of the application with regard to which the key has pressed. That is, it divides the message into different application for which it is built. Let us now see what happens to be done if we are to alter this procedure. That is, what is how this can be done. That is how to mold this procedure. We simply need to register our hook procedure with the operating system. That is how these steps are carried out, how this is possible, by simply registering to the hook, procedure with the operating system. As a result, our hook procedure would receive the message before it is dispatched to the appropriate application message queue. That is, this is the main reason our hook procedure, that is the procedure of the hook, would receive the message before it is going, or before it is dispatched to the appropriate application message queue. Since our hook procedure gets a first shot at the message, it can now alter the working in following 3 ways. What are the 3 ways in which we can alter the working? First of all, it can suppress the message altogether. That is, keyboard controller or the system or the hook procedure suppresses the message altogether. Then it can change the message. The next point is, it can change the message that is available. Then it can post more messages into the system message queue using the keyboard event function. So these are the 3 parts that is available. That means it can suppress. It means the procedure or the hook procedure, that is a hooking procedure, that is a hook part that can suppress the message altogether. Suppress means shrink the message altogether, or it can change the message, that is the hooking can also change the message. It can post more messages into the system message queue using the keyboard event function. Then let us now put all this theory into practice by writing a few programs. Now, what are the few programs that is available? One is caps locked permanently, that is a caps lock permanently. Let us now write a program that keeps the caps lock permanently on. So this is the program that shows how to keep the cap lock permanently on. This effect would come into being when the first key is hit subsequent to the execution of our program. So this effect would come into the picture when the first key is hit, or when the first key is hitting subsequent to the execution of our program. In fact, there would be two programs. That is available. What are the two programs? The first program is a DLL that contains a hook procedure that achieves the caps lock effect. So there is the DLL that contains a hook procedure that achieves the caps lock effect, that is available with the DLL. Then application exe, which loads the DLL in the memory. That is application executable file that loads the DLL in the memory. Given below is the source code of the DLL program. So this is the code for the DLL program. There is a hook.c. This is the hash include windows.h, that is a Windows file. Then static h hook hkb. This is the variable name, that is the hkb, that is equals to the null. Then handle h. This is also a variable that is of handle type. Then there is a bool std call DLL main. So this is also a function that is used. Then handle h module dword ul reason fork call lp void lp reserved. So these are the various variables that is used in this one. These are the various parameters. Then there is a h equals to h module. So this is the h module is the function. H module is the output of h module is going, or the variable is storing the h module in h. Then there is a return true, that is returning the true. That means the output is correct. Then there is a next function, that is a bool dec ls special, that is a dec special. There are two arguments. There is one argument that is a DLL export. Then there is a function that is a install hook function, and then the variable is used, that is a hpk, that is able to store the output of the function, that is a set windows hook x function. Then check the condition. If hkb equals to null, that is equals to the null, then return false, otherwise returns true, and then close this function. Then there is a L result, that is a dec this one. Then there is a short int space. Then again check the condition. If it is less than 0, then return this one, and if it is equals to this one and this one, then this is the next condition. This is the next part. So this is the following are the steps, that is how to use this one. So these are the various steps that is given, that is how to execute in the C++, how to make this program run. So if it is equal to the H action, SC action, and the next action, then this is the result, or this is the program, or this is the function for the L result, DECL spec, then DLL export, then std call keyboard proc, wparam, wparam, lparam, lparam. Then there is a variable that is declared, that is a short int, that the variable name is state. So state is the name of the variable and it is of int type. Then check the condition. If encode is less than 0, then return this one, that is code next hook x hbk encode wparam iparam. Otherwise it check for this one, that is if it is equals to h action and d word iparam and this one, then state equals to get key state, that is the vk capital. Then again check the condition. If it is off, that is the state &1 is equal to off. Then keyboard event, then vk capital 0, keyboard event extended key 0. Then there is a keyboard event vk capital 0 even tf extended key up, that is for the extended up, keyboard up, then there is a 0. Then there is a return call next hook x, that is calling the hook procedure, and there are various argument in this, there are various parameter in this like hbk encode wparam iparam. Then it is used as a bool, then decl spec, then dll export. Then there is a bool function that is used. Then there is a remove hook, this is a function that is used, and there is a return, that is unhook windows hook x, that there is a hbk that is used, that is the hbk function is used. And then next line says following are the steps that is mentioned below to create the program. So following are the steps that is mentioned below to create this program that is used. First of all, it is using, or first point says select the file, then go to the new option to start a new project in VC++. That is simply go to the file menu, go to the file, then go to the new option to start a new project in the VC++. Then from the project tab, select Win32 dynamic link library, that is select this one, that is a Win32 dynamic link library, and click on the next button, that is the next part, that is the next step. Then the third one says in the window 2, so first of all go to the file, click on the next, then select the Window32 dynamic link library, click on the next button. Then C point says in the Window32 dynamic link library, step 1 of 1, select an empty DLL project and then click on the finish button. That is select on the this topic, or select on the message that is an empty DLL project and then click on the finish button. Then next point says select file, then go to the new option. Then E point says from the file tab select C++ source file, that is go to the file tab, then select C++ source file and give the file name as a hook.c. This is the name of the file with the extension .c, that is hook.c. Type the code listed above in this file. So these are the various procedures, that is how to write the code. So first of all go to the file, then new option, then go to the project tab, select the Win32 dynamic link library, then click on the next button. Then C point says in the Window32 library, select an empty DLL project and then click on the finish button. Then select file, new option. From the file tab select C++ source file and give the file name as a hook.c. That is give the file name, select the message as C++ source file and give the file name as a hook.c. Then type the code that is listed above in this file. Then at last at the end compile the program to generate the .dll file. That is compilation of the program to generate the .dll file. Note that this program does not contain win main function, since the program on compilation should not execute on its own. That is, this does not contain, or this does not have a win main function, since the program on compilation should not execute on its own. It has been replaced by a function that is known as the DLL main function. So when we are doing the Windows programming, we have used the function that is the window main function, that is the win main function, and for this that is for keyboard, there is a function that is the main function that is known as the DLL main function. This function acts as the entry point of the DLL program. Like in DOS, there is a void main. In Windows, there is a win main. In the same way, in the function or in the communication with the keyboard, there is a function that is known as the DLL main. This function acts as the entry point of the DLL program. It gets called when the DLL is loaded or unloaded. Right. Next point says when the application loads the DLL main function would be called. So whenever there is an application or when the application loads the DLL main function would be called. In this function, we have merely stored the handle to the DLL that has loaded in the memory into a global variable H for later usage. So this is stored in H for the later usage. This is stored in for the later usage. That is a H module. Those functions in a DLL that can be called from outside it are known as the exported function. So that can be called from the outside, that is known as the exported functions. RDLL functions or RDLL contain three such functions, that is three main functions, that is the install hook, then remove hook, then keyboard proc. These are the three functions that is available. One is known as the install hook, that is how to install the hook, then remove hook, then keyboard procedure. To indicate to the compiler that a function in a DLL is an exported function, we have to pre-qualify it with the decl, that is a DLL export, that is a decl spec. These functions would be called from the second program. The second program is a normal GUI program, that is a graphical user application that is used or that is created in the same way when we did the applications in the chapter number 17 and 18. There are two messages that is used in the same way it is used, that is the WM create and the WM destroy. So these are the two messages that is used, that is the WM create and the WM destroy messages. Then this is the program that is used or that is given below. One is the first of all there is a caps lock. This is the program for the caps lock. There is a H instance that is for initialization. There is a H that is a variable. Then void on create. This is a function that is used, that is the on create function, the same as we done in the Windows programming. The return type is void and the argument that is used in the HWND. Then there is a bool, then callback pointer P. This bool function is used and the variable argument that is used is the callback pointer P. Then uses the function that is the load library function and stores the output of load library into the H. That is a load library hook.dll. So hook is a DLL file that is used, that is hook.dll. Then check the condition. If H is not equals to null, that is if it is not equals to null, then P equals to get proc address, that is P is getting the value or P is storing the value of the function, that is a get proc address. And there are two arguments that is used in this, that is the H and install hook. Then there is a function calling, that is a pointer P. Then the next one is used, that is the void on destroy function. So one is the on create function, then next is the on destroy function. That is again the return type is void. Then there is a HWND. Then there is a bool callback pointer P. This is the function that is used. Then the get proc address function is used for making the get proc, that is the H remove hook. Then pointer P is used. Then there is a free library function is called for freeing the DLL, that is for empty the DLL, that is done by the free library. Then H, then post quit message, there is a 0. So as we know, on create and on destroy handlers would be called when the WM create and the WM destroy messages arrives respectively. So whenever there is a messages that arrives like WM create and WM destroy, these are the two functions that will be used. That is the function that is the on create function and the on destroy function. In on create function we have uploaded or we have loaded the DLL containing the hook procedure. To do this, we have called the load library API function. Once the DLL is loaded, we have obtained the address of the exported function, that is the install hook function, using the get proc address function. So this is the exported function that is used. that is the install hook function using the get proc address API function. The return address is stored in the P, that is the return address that is stored in P, where P is a pointer to the install hook function. So this P is used as a pointer to the install hook function. In the install hook function, we have called the API function that is known as the set windows hook X to register our hook procedure with the operating system as shown below. This is a function that is used, that is the HBK equals to set windows hook X WH keyboard hook procedure keyboard proc H instance H0. Here the first parameter is the type of hook that we wish to register, whereas the second parameter, that is the first parameter, is the WH keyboard, that is a type of hook, that is a keyboard hook is used, whereas the second parameter is the address over a hook procedure, that is a keyboard proc. HBK stores the handle of the hook installed, that is the HBK. This is the variable. From now on, whenever a keyboard mouse is retrieved by the OS from the system queue, the message is firstly passed to the hook procedure, that is a keyboard proc function. So whenever there is any hit key or whenever we press any key with the keyboard, so first of all it is going to the, or first of all it is going to the keyboard proc function, that is the hook procedure function. Inside this function we have written the code to ensure that the caps lock always remains on. So this is the function that is stored in this one, that is the caps lock is always on. To begin, we have checked whether encode parameter is less than 0. If it's so, it is necessary to call the next hook procedure. The MSDN documentation suggests if the code is less than 0, the hook procedure pass the function to the call next hook X function without further processing and should return the value returned by the call hook next hook X function. Then this says, note that there can be several hook procedure installed by different programs, therefore forming a chain of hook procedures. These hook procedures always get scored in a order, that is it is used in the order in which they are used, that is opposite to their order of installation. That means the last hook procedure installed is the first one to be called, that is the first one that is to be called, that is the last procedure that is used for the procedure. Then next point says, if the encode parameter contains a value that is H action, it means that the message that was first just removed from the system queue was a keyboard message, that is the H action. If it is so, then we have checked the previous state of the key before the message was sent. If the state of the key was depressed, that is it is depressed, that the 30th bit of the I param is 1, then we have obtained the state of the caps lock key by calling the get key state API function. If it is off, that is the 0 bit of state variable is 0, then we have turned the caps lock by simulating a key press. For this we have used a function that is a keyboard event function. The parameter, that is the VK capital, represents the code for the caps lock key. When we close the application window, as usual, the on destroy function will be called. So this is a function that is called as usual, that is the on destroy function in the program. This is the on destroy function whenever we finish with the applications. In this handler, or in this, we have obtained the address of the remove hook exported function. That is, we have removed the function that is a remove hook, or we have used the function, we have obtained the address of the remove hook exported function and called it. In the remove hook function, we have unregistered our hook procedure by knowing or by calling the unhook windows hook X API function. So these are the two functions that is used whenever we use the on destroy function. One is the remove hook and one is the unhook windows hook X API function. As a result, our hook procedure is now removed from the hook chain. Hereafter, the caps lock would behave normally. Then we have to check or we have to control the hook procedure by using the function that is the onDestroy handler. Whenever we have promptly unload the DLL from memory by using the function that is the free library function. So the free library is a function that is also a library function for freeing the memory, that is also the API function. Our last point about this program, that is a hook.dll file, should be copied into the directory of the application, that is exe before execution. That is, this is a program that shows how hook procedure will call, how onCreate function is used, how delete function is, onDestroy function is used. One is the onCreate, one is the onDestroy function.